Hello there. I'm at my battery. This battery is inside this case is charged with my wind turbine. I'm currently charging up my cell phone. But the reason why I'm recording this video today is to talk about this USB charger. I've had this for a couple of years, I guess, and it used to work fine, but it's acting flaky on me now. So if I plug it into my battery, my 12-volt battery, the light turns on and it looks like it's working. I have a USB powered fan, runs on 5 volts. I should be able to plug the fan into the USB adapter and power it up. So you can see it's powering right now, but then it stops and then starts and stops and starts. It's not supposed to stop and start, it's just supposed to stay on. So it's on, but then it turns off. So why is it doing that? And it's not this splitter because I've also had problems with that in other 12-volt jacks too. I'm wondering if I can fix this USB power supply. I'd like to open it up and take a look inside and see if there's anything I can do. There are no screws, so it looks like there's just a sticker here. I'll get a screwdriver and see if I can just pry it open. Oh yeah, that was pretty easy. Open it up and take our first look. I've always wondered, whoa! Oh, there's a fuse. This clip makes no electrical contact with anything. It converted 12 to 24 volts input to an output of 5 volts. It looks like a simple circuit. The battery is currently at over 12 volts. So I'm going to disconnect the multimeter. I'm going to connect this circuit in its place. I do have a fuse connected to my battery, so... Well, the light did not turn on. Okay, I've connected the multimeter directly to the USB converter, so we can see what the voltage input is. So I'm going to connect the battery and the voltage should be around 12 volts. Alright, so we have an input of 12 volts, but the LED is not turning on. So I'm going to disconnect it. It'd be interesting to look at that. Even though I've disconnected my battery, there's still a voltage across those capacitors. This black piece sticking up in the middle, it looks like a transistor. It's a voltage regulator. I looked the part number up on the internet and found out what the input pins were and the output pins. And this is the heart of the voltage converter. The voltage regulator is the main component of this little circuit. So first, I'm going to measure the input voltage on the voltage regulator. Okay, we're getting 12 volts, and that's what we would expect. Now, let's measure the output voltage. And the output is no change. We're just measuring the voltage of the capacitor right now, and it's just about 0 volts. There is no output voltage on that little voltage regulator. The voltage regulator must be fried. I think if I replace that voltage regulator, it's like a 25-cent piece. If I replace that, and then this device would work again. I have a couple of options here. One is to simply buy a replacement regulator, or I could open up another 12 volt converter and hope that there's a compatible voltage regulator inside. I don't think I'm going to rip open one of these though. I don't want to damage it. For now, I'm going to put this back together again until I can find a replacement part. Another option is to say forget trying to fix this thing and just buy another one. I don't really like that answer though, or that option. Another good thing about trying to fix this is that I'm learning while I fix. I'm learning while I fix it, which might help me or give me some skills that I could use on another project. There, it's back together again, even though it's not working. The label says a maximum of 1000 milliamps, which is 1 amp. But I think that's an error because the voltage regulator says the voltage regulator inside is only rated at 100 milliamps max. So it's possible that maybe this fan or some other device I've plugged into the USB converter drew more current than this was designed for, and it's possible the voltage regulator burned up.